I'll let you guys do your setups right now if you want to highlight the triangles with your colored pencils because they do overlap, it looks like. Okay, we're ready to talk to each other here. Quickly, can we review 5 methods proving triangles congruent? I know it's been not too long, but it's been enough time. Angle, side angle, AAS. Anybody? Come on. SAS. All right, don't forget about it. Right? I tried to warn you guys. That's always. But we're not even going to need it here. How do I know? Yeah, we're not even dealing with right triangles. So see you later. I got those 4 now. All right, let's see. I also want to talk. Did I give you any full sides or full angles? TR and TS, are those full sides or full angles in these 2 triangles I highlighted? No, they're not, but I'm probably going to have to use them somehow, right? Those are congruent. I can't put an S next to it, but how about TM and TN? No. Oh boy, guys, look at what am I trying to tell you? I gave you nothing. I've given you no sides or no angles. All 3 pair are on you guys right now. I did not provide any sides or any angles. So you guys need to come up with all 3 on your own. All right, we could go anywhere we want here. Grace, subtraction to get which sides?
To get MR and MS.
Everyone good? Subtraction? Yeah. And I already have the 2 quantities, equal quantities, right? So I can go right to step 2, subtract. TR minus TM equals TS minus TN. Subtraction. I'm just subtracting the givens. That's all I'm doing. And then this hasn't changed, right? Right after subtraction, your good old substitution. To say, let's see, MR congruent to NS. 2, 3, 1, 2, 3. And that gives me a pair of sides. All right, 1 down, 2 to go. Good job, everybody. 1 down, 2 to go. Tim, where do you want to go next?
We can do RS congruent to RS.
Everyone see full side RS shared by both? They overlap each other. Great job, everyone. RS congruent to itself. Hopefully some of you guys are geez, this is getting a little tougher. RS, reflexive. There's another S for us. Okay, so either you're going to need to find me a 3rd side or the angle in between those 2 sides. That's what I've narrowed it down to. It's got to be side, side, or side angle side. So it's either the 3rd pair of sides or the angle in between those 2 sides we just got by substitution and reflexive. Ooh, here we go. Now it gets tough. Where is that 3rd pair? Where is that 3rd pair? Think you got something, Maddie? Maybe. All right, sure. I like the confidence.
On Friday,
yeah,
we did. The 2 sides are equal on either side, and so the 2 inner angles should be equal too.
Okay, so Maddie's basically saying, everybody, TRS is what type of triangle? TRS is isosceles, correct. So that means across from TS and TR are what? Congruent angles. Everyone see that? Because TS and TR are equal, the angles across from them are equal, which would be what angles for us? Angle MR or TM or TRS, MRS, it doesn't matter. MRS, which is an angle in one of the triangles I need, is congruent to, on the other side, NSR. Good. And if you remember, I think we wrote it 3 times on one problem. In a triangle. Anybody want to finish that? In a triangle, congruent. Uh-oh, do we have to go back and look?
In a triangle, congruent angles are across from.
Yep, congruent angles. And again, I don't care if you use angles or sides here. It doesn't matter if you flip them. Congruent angles are across from congruent sides. And again, if you say, if the word sides and angles are switched, I'm not going to be picky at all. And that gives me my pair of angles that I was looking for. So start looking for isosceles triangles. We got enough, right? Triangle RMS is now congruent to triangle RNS. Side angle, side. Get any tougher, you think? Little tougher? Huh? Maybe? Wait till you see the last one we do. All right, questions on this one? All right, I think I'm confident enough to let you guys work together on the next one. Looks like these are also overlapping, so take your time. Go ahead, talk to each other, see what you guys can do here. Don't go on to the next one. We're going to do the next one together. But this one, I think you guys can try out together. Remember, try to make a plan before you write down step 2. Did he give me any sides or angles I can start with? Talk it through. Can I at least ask you guys, did I give you any full sides or angles?
Yeah.
Which pair up here? Which of the 2 givens were actual full sides? Okay, that was it. So I gave you a pair of sides. You're on the hook for the other 2 pairs something. Go ahead. You got it? You got it? Come on, talk. All right, tell me something. Anything that's true. 5, anything that's true. Wish we had a 5.
Oh, are we doing the same?
Actually, you know what? We should have been going back. I forgot that you guys did actual numbers, so I don't have to keep doing this, right?
Yeah, that would have been.
Relax, Grace. I'll teach. What's the highest number we have in here? 14, 15?
13.
13?
Yeah.
I only have 13 in this class? Does everyone have a number? Not your desk number, but a number so I don't have to keep generating. 13. Well, Eric, 1 came up regardless. Give me something that's true. Okay. I don't know why he's telling me that, but I'm sure you guys know, right? And somebody will add on to that. Nothing. Never mind. It was a poor attempt at a add on to it. Never mind. Oh boy. I thought this class had a little bit of personality. 9. What else you got for me?
Angle A is congruent to angle D.
Oh, wow. You're going off script. Yep, angle A is congruent to angle D because in a triangle, the big one's isosceles. So in a triangle, Congruent angles are across from congruent sides. Good, that gives me a pair of angles, yep. All right, next up, we're rolling, I like it. Hey, 8, what's up next?
AC minus BC congruent to DB minus BC.
Okay, I don't want to do subtraction though. Because remember, you're telling me AC.
Oh, yeah, I meant addition.
Oh, did you?
Yeah.
Even though you clearly said minus all the way through? Yeah.
AC plus BC is congruent to DB plus BC.
Okay, hold on. If I do AC plus BC, I'm getting longer. I don't think I want AC to add to BC. What were the two congruent sides I gave you at the beginning? AB and CD, right? So I want to take AB and add it to BC. Do you see how if I took AC and added it to BC, I get a much, much longer side? Okay, and then go ahead, redeem yourself. So I do AB plus BC. What about on the other triangle?
DC plus CD.
There you go. Redeemed. Addition. And then we have our substitution, right? To say AC congruent to BD. That gives me my other side, right? And then everyone good? Side angle side? With these? Everyone good? I'll just write side angle side here. All right. Any issues? Going? Ask questions. Questions? Okay. Now, these last two have been isosceles triangles. What if now I'm asking you, can you show me that this triangle is isosceles? Now, prove to me this triangle is isosceles. So my question to you guys, what makes a triangle isosceles? I either have two sides equal, or what did we learn on Friday? Not only, I could have two sides, or I could go two angles. So show me this triangle either has two sides congruent to each other, or it has two angles. And then you'll have an isosceles triangle. So can you get me either two of the sides or two of the angles? Whatever comes first. Whatever can come first. So I gave you 3 congruent to 4. Anybody remember a former theorem that may help here? Supplements of congruent angles are congruent, but you better tell me what angles are supplementary first. Yes, that's what we're going to do here. Supplements of congruent angles are congruent, but I do need to know which angles are supplementary. So we'll start with angle 1 and angle 3 are supplementary. Angle 2 and angle 4 are supplementary. That's not by supplements of congruent angles, though. That's because these are all what? Linear pairs, yeah. Machines, this class. Linear pairs are supplementary. I go too fast on this one. We all right? 3. Now you can tell me angle 1 and 2 are congruent. Supplements of congruent angles are congruent. Good work. Now, you can stop here. Did I just get 2 congruent angles in that triangle? Is it isosceles now? Yes. Now, if you wanted to add on and try to impress people, could I have said that now that 1 and 2 are equal, AB and AC are equal? In a triangle, congruent sides are across from congruent angles, you could. It's just an extra step. You're just doing it a different way, but we can stop here and say triangle ABC is isosceles. Ooh, what do you think the reason's going to be? How's it? Look at the work we just did. Why is it isosceles now? Good, right? What's up?
In a triangle, congruent sides are across from congruent angles.
That would be saying AB and AC are equal. I want you to tell me how you know it's isosceles. Why is this isosceles now that we just finished step 3?
two of the sides are congruent?
Did we say two of the sides are equal?
I don't know.
Well, you're there. I know I'm being picky, but we didn't say two of the sides were equal. We said two of the what are equal instead. Okay, so two angles congruent imply isosceles triangle. There you go. You had it. Just needed the angles because we didn't have the sides. If you did prove the sides, now I substitute in sides. Two sides congruent implies an isosceles triangle. Whoa, before you might not want to turn that page so fast. Are we good here before we get to that thing? Because that thing is hot, that last proof. We sure we're good here. All right, let's do it. This thing is hot. Woo. Anybody scared or nervous? I don't want to hype it up too much, but look at that thing. Look at this diagram. Unbelievable. I got 9 different angles labeled. 9, kids. 9. All right, let's do it. 1 is congruent to 9. And I even marked it for you. Nice. 1 and 9. I even marked AB congruent to GF. And triangle CDE. Okay, before we start, I do want to talk about one of the givens. So we're all on, I'll get everyone on the same page here. I do want to talk about one of the givens. All right, right here, this given. Saying that triangle CDE is isosceles with base CE. Okay, so CDE is isosceles, which means it's got 2 sides congruent, right? I got to know which 2 sides. I just don't assume left and right. I can't assume that. I got to figure out which 2 sides is congruent if that's an isosceles triangle. That's why they gave you base CE. Anybody remember a vocab from Friday? Base is the, not bottom, but it's the non-congruent side. So CE is the non-congruent side, which tells me what about my isosceles triangle? That CD is congruent to DE. And I don't need to write that down. That's given right here in that statement. So just to make sure you guys are all clear, yes, it's isosceles, but they better tell me what the base is or what the 2 congruent sides are. Because I just don't assume left and right every time. It's those 2 sides. So everyone understand why they gave me base CE here. All right, let's go now. 1 congruent to 9. That's a pair of angles in those triangles, right? AB and GF. Am I overhyping this? I already gave you 2 out of 3. What's up, Misha?
Wouldn't angle 4 be congruent to angle 6?
We can start there. You are correct. 4 is congruent to 6. How'd you know that? That was good.
Isosceles triangles imply congruent angles.
That's fine. I'd still use our old theorem just to be on the safe side in a triangle. Yeah, you can still use that. Congruent angles are across from congruent sides. But what you said is fine too. I definitely accept what you had. Congruent angles are across from congruent sides. Yep. So let's see. I mark 4 and 6 equal. Yep, good. Still searching, right, for something here. Hi, Maddie.
4 and 2 and 6 and 7 are vertical angles.
Okay, can I You guys know how I feel. I don't like writing it in the same step. I like separating them so you guys can see where the substitution is going to come into play. So just give me one of them to start with.
Okay, 2 and 4.
Okay. 2 congruent to 4. Vertical angles are congruent. I like, and yet, now look, sure, could you just write in, what's the other one there we just wrote? 6 and 7 are equal, vertical, sure, but I like to keep them separated because I don't know how many of us are still at the point where this is going to be more than one substitution. Look at 2 and 3. What angles do you now know are equal after steps 2 and 3? 4 is equal to 6, 2 is equal to 4. What angles have to be congruent now? 6 and, well, I got 6 and 4. Well, not yet. I don't want to go that route yet. I got too many equal. I'm going to have write down too many. Just using these two right now. Just solely looking at these two. 6 and 2. That's using what? Substitution. Number 1. Substitution number 1. All right, so I have 6 and 2 equal. Now, Maddie, go ahead. What are the other pair of verts?
6 and 7.
Now, you guys starting to see why I like this all separated here? 6 congruent to 7. I don't know if you would have seen it. It is 2 substitutions to lead to what 2 angles being congruent now? 2n.
7.
2 and 7. 6 equals 2. 6 equals 7. So 2 equals 7. Everyone see it took us 2 substitutions. Oh, sorry. Vertical angles are congruent. Are we seeing it took us 2 substitutions to get here? If you guys put the 2 vertical angles in one step, would you said 2? I don't know. Maybe. Or some of you may have just went substitution once and got 2 congruent to 7. But do we see the 2 substitutions in play? 2 congruent to 7. That gives me another pair of angles. I think you guys should have a method for me now. Triangle ABC and GFE. I don't even know the method yet. I got to take a quick peek here. What's this method?
Angle, side.
AB. Is this side in between? Nope. So I got to go angle, side. What'd you think of that one, Lucy, huh? Good talk. Always a pleasure. Hi, Maisha, go ahead.
Do you have to do all of that just to get 207?
No, you look at the vertical angle step. I could have said 2 congruent to 4, 6 congruent to 7, all in this step. But I better see at least 6 congruent to 2 and then 2 congruent to 7 in one substitution step. If you just go from, because here's what I'm worried about. You guys are going to go 2 congruent to 4, 6 congruent to 7 in this step here. And then all of a sudden 2 and 7 are going to pop out of nowhere. One substitution. Even though it clearly took 2 substitutions to do that. If you can handle it going all in one, I'm fine with it. At this point in the year, I'm fine. But I'd just like to separate it so you guys know, hey, I needed 2 substitutions. Tim.
If it gives you that the triangles isosceles, do you have to say that the 2 angles are congruent?
Yes. Because notice it said base CE, so all I know is the other 2 sides are the legs that are congruent. Your knowledge now says, oh, because those 2 are congruent, the angles across are equal. Okay, yes, yep, I do need to see that. All right, I'm good. You guys then get rolling. Watch for overlapping triangles. That was one of the longer classes we had, but that's fine.